Hello everybody, this is going to be a little bit of a one-off video that we're doing here in commemoration of, well, commemoration, celebration, all those sorts of things of the Falcon Heavy launch that just happened today where, well, we happen to have a flying car. It has finally happened, but not quite the way we originally thought it was going to be, at least as we were growing up and hearing about all those sorts of things. So I kind of have a Falcon Heavy-esque kind of rocket. Guess this is a little longer than it should be, and I actually have a crew. Valentina has volunteered to fly. I have not flown this craft yet at all. We're just kind of one off it and talk a little bit about the Falcon Heavy and orbital mechanics, because I've had some other people talk to me from time to time about, well, how does he get to the moon, or how do you get to the Tesla to Mars, and how do all these things work, and how do you know how these things work? And well, let's talk about it. So I think I have the staging all correct. If we don't get to Mars, well, we don't get to Mars. We'll see what happens. But 3, 2, 1, fire. And that was a lot slower of a liftoff than I thought it was going to be. Oh yeah, my thrust to weight ratio is a little low. Okay, well, anyways, we are taking off. We are firing, and we are headed to space. So a lot of people think, first off, their rockets go straight up. Not the case. If you want to understand how an orbit works, think of it this way. Gravity is always pulling us down, right? And even when you're way up in space, gravity is still affecting you, whether it be from Earth, or from the sun, or from any other object out there. Laws of physics state that any two objects of any sort of mass will attract each other at some point, depending on distance between them and of course the mass of the object. So of course your Earth is going to attract you a lot more than, well, the car that's sitting next to you, or whatever, even the person sitting next to you. So we're going to want to tip over a little bit here as we're starting to go up, and hope for a minute here that my pressures, I might be doing that a little soon, we'll see. It's not ideal, but we're going to start tipping over a little bit. Real life, they start tipping over pretty quick. I noticed that. I mean, we're only about 9 kilometers up now, so we are definitely going to start kicking over. Now, the reason for this, getting back to the gravity portion, of course, is an orbit is basically the fact that you are always falling towards Earth. If you are up in space, you are falling towards the Earth, unless you're far enough away that you're going to be falling towards something else. We're going to try to talk here while flying this sucker. This thing's a little unstable up in this atmosphere here. Let's not lose it. We've passed max Q, that's for sure. Our boosters are about to run out here, so I'm waiting for that for separation here. And boosters are out. We are going to separate them out. Now, of course, in the real SpaceX mission, those boosters would actually turn around and would go back and land at the launch pad. Now, I do not have the ability to do that in KSP. I don't have the mods for it, so we're not going to worry about that. We'll just say those boosters are headed down. Now we're just on the core right now. Starting to really lean over here. So basically, if you think about it this way, our Earth below us, or in the game Kerbin, is pulling us down at all times. So if we want to get to an orbit here, we need to be traveling sideways fast enough so that as we fall, we just continually basically fall along the curve of the planet. So you'll see here, if I go to orbital mode here, and there are some other spacecraft up here apparently, you can see the arc that we are traveling here. Now, obviously we're not going to go to space anytime soon with this kind of an arc. But if we can get enough sideways speed, and in Kerbin, it's about 22 to 2300 meters per second at this altitude, we will get a perfect circle. Alright? So all I'm doing right now is just burning sideways, getting ourselves some acceleration here. I'm actually going to pick up my thrust limiter here. We're going to throttle our engine all the way up here, try to get some momentum here. We've actually just crashed into space, or the threshold of space. So This actual section here, in the Falcon Heavy, of course, was much shorter. Main engine cutout on the core was not long after the boosters cut out. I had quite a bit more fuel on top of this, and I also limited the thrust on this rocket here just to kind of get myself enough delta V, which is the ability for the rocket to propel itself, create momentum basically. I wanted to increase that as much as possible, and it actually looks like I might have enough fuel in this stage here to get into orbit by accident. So it's not going to be a perfect Falcon Heavy style launch here. I'm just watching my numbers here. Oh, actually we just ran out of fuel and we are not quite in orbit. So with that, I'm going to cut throttle and we are going to separate out here. And I do not want my parachute launching. That would be bad. I don't even know why I have a parachute on this, to be honest. I think it's just a it's just kind of habit, if you will. So if you look here, we've actually now got ourselves a bit of a circle. I'm going to accelerate time. So when we start talking about orbital mechanics, things get a little funky, because when you're dealing with this gravity well, that is the Earth or Kerbin in this area, or in this game, you are going to be dealing with the fact that whatever you do on one side of the orbit affects the other side of the orbit. I know it's a little screwy, but think of it this way. If we start accelerating faster here, we're going to put more energy into it. Well, we're still in this circular orbit, so by putting more energy in it, we're going to swing out further away from the gravity well, and then we're going to fall back down in when we get to that, get back around. So you're always going to have this apoapsis, which is your highest point, and a periapsis at your lowest point. So if you want to maximize your energy, your fuel, you're going to want to burn at your apoapsis when you want to get your periapsis higher, and if you want to shrink stuff down, you're going to want to do it at your periapsis. That's actually something known as the Oberth effect. I won't get into it too heavily, but basically it states that you're going to conserve more energy. So you're going to do, we should, oh, I don't want docking. I want regular staging. There we go. We need to fire that rocket. And somehow it seems to think that it was firing. There we go. So you can see here, as I'm accelerating, it actually looks like it's switching positions. But what happens is our periapsis, where we were at 79,000, is here, and now the faster point in our orbit is going to be here. So basically, if you wanted to get to the moon here, all you have to do is accelerate this out. And you're going to keep accelerating until your apoapsis gets out here. Well, actually you're going to want to be about right here because of the swing of the moon. That's basically how the Apollo astronauts did it. Of course, they set up what was known as a free return trajectory, so they would accelerate out here, and when they got out to the moon would actually start pulling them in, because when you get close enough to another body, that body will actually affect your gravity or your orbit, because it's pulling you in more than the original body that you were orbiting. Now in this game, everything's based on single body gravitational effects. So I'm either affected by Kerbin, or I'm affected by the moon, or if I zoom way out, at some point I become affected by the sun. In real life, you're actually always getting pulled from all different areas, and you have to do the math of it, of course, and nothing's ever quite perfect, although our computers are pretty good at that. So now the question is, what people have been asking me, how do you get to Mars? Well, Juna here is actually the Mars equivalent in Kerbal Space Program. Now most people think, well, just accelerate towards it, right? Well, the problem is, first of all, if you accelerate towards it, all you're really doing is going to affect the other side of your orbit. Now I know what you're thinking, I'm orbiting here, I'm not orbiting here, but technically you are orbiting out here. You might be going around the Earth, but remember, the Earth or Kerbin in the game, is orbiting around the sun. So in reality, if you think of it in layman's terms, because you're orbiting, you're actually probably going like this, zigzagging back and forth, but your true path is still in orbit. Now, of course, I'm exaggerating this quite a bit, but you are still orbiting here. So, in order to do that, you basically need to accelerate your orbit here so that on the other side, your orbit becomes close to the orbit of the planet you're trying to get to. Now, it just so happens that at this moment in time, I'm actually in the proper phase for getting to Duna, to getting to Mars. Now, Falcon Heavy is not actually going to get there. They're going to get close, but they're just basically going to be in this orbit here, which is going to have a low point here and a high point. Let me zoom out a little bit more, in Mars orbit. So they're just basically going to keep accelerating out here, slow down, and then accelerate back to where Earth's orbit is, and just keep going. Probably for thousands and thousands of years if nothing gets close enough to affect its trajectory. Although if it gets close enough to either Earth or Mars, the trajectory could go somewhere else. But you will always be around a circle here in the sun, because that is the biggest gravity well in our solar system. That's why all the planets are orbiting as well, because they are orbiting the largest gravity well within the system. So everything is based off of gravity and basically circles. So in this case, we want to accelerate, okay? Because we're going outside of our Earth's orbit, so we need to start going faster. We need to do it over here. So we need to line up the fact that we want to go this way, because this is the direction we are orbiting. And we got to look, and actually we are darn near close to going in the right direction. So I'm actually going to point in the prograde direction, and I'm just going to start firing. Now first, and I gotta watch here, I don't know if I have enough, I think I have enough fuel to do this. I'm sorry if the sound gets a little off here. So you'll see here, all we're going to start doing is stretching out our apoapsis. Of course, that doesn't seem to be doing what we want to do, right? We're just accelerating inside of here. We're not doing anything with our orbit here. Well, that's because we can't see it, because we are still too much affected by the Earth's orbit. We need to go faster. And I think I'm almost in the right phase angle here. I might have started burning a little bit late, but I'm kind of doing this by the seat of my pants here. We'll see. So we're just going to keep burning here. You'll see here, now we're going to get to the moon's orbit. In the game, there's a secondary moon, obviously, called Minmus. So we're going to ignore that. And I'm going to start slowing down here a little bit, so you can see what goes here, or what goes on here. Now, right now, I'm going to stop. If we stop right here, we will swing way out here, but we won't get far enough away, and Kerbin's gravity well will still pull us back in, alright? So we need to go a little faster. Now, we have what's known as an escape, meaning that we're going to get far enough away from Kerbin, or Earth, that we will lose our capture, and we'll actually get into a sun orbit. Let's set this as our target. Setting node looks good. Okay, I don't think I have this quite right, but we're gonna burn and see how close we can get. It may end up being more of a Falcon Heavy approach here, but we'll see how well we do. So you can see here our predicted orbit is gonna show us getting, oh, I actually nailed the transit. I actually got to slow down a little bit. I went a little too far. So let's correct this quick. I'm going to go retrograde a little bit, slow down, pull a little bit of energy out of my orbit here. There we go. Perfect. So let me show you what's happening. Now you'll see here our speed is slowing down. The reason being is that, as you can see, well, actually you can't see because we are on the dark side right now. Well, we got a lot of fuel left. Holy cow. Alright, let's zoom back in. So we are continuing our orbit, but what we're doing is, as we start to accelerate, we are going to move away from the planet. And as we do so, gravity is affecting us. So gravity is slowing us down. What we needed was enough energy, in this case it'd be meters per second, enough energy to escape this gravity well. Now we're going to keep accelerating. Now we're headed out past the moon's orbit. This is just a communication line for the game. I'm not too worried about it because we have a Kerbal inside to communicate with. I see. Ooh, let's not go too fast here. I don't know why. Oh, full crew control. Okay, so now we're getting out to Minimus orbit. You'll see we're slowing down, we're slowing down, we're slowing down. It's like, how are we going to get anywhere if we're going this slow? Well, remember, this speed is relative to Earth, or Kerbin in this area, in this general mindset. So we may be slowing down here. Oh, really? Hold on a second. What is the debug menu? I forget what the debug menu is. UI flight. Hold on. Oop, not that. I want this. Because, yeah, we're showing getting low. Okay, so I can't do this way. I need the debug menu. I forget my keep codes here. Problem is I'm running a modded save. This is my normal save that I play in. So it has... it has mods, including life support, which I forgot about. And I thought I remembered what it was, but apparently... so it should be Alt F12. Okay, there we go. Perfect. Cheats. Infinite... resources. I think that's going to do it. Let me check here. It's still running out. Food depleted. Okay, this is maybe not working as well as I wanted. The question is, okay, we still have a Kerbal. How long are we going to have a Kerbal? I'm hoping that it holds it at 0. Oh, you know what I didn't? Oh, there. I just... Okay, well. Alright, so we lost our Kerbal. That's what happens when you don't run with life support. Regardless, we're still going to have our orbit here. So you'll see here, because we accelerated enough, our little planet here is moving away from our spacecraft. I want to say aircraft is moving away from Kerbin and accelerating out. Okay, because we're using the sun as our gravity well. If you look, our speed now went from 1,000 to probably it was about 12 to 13,000 meters per second. So that was the actual speed they were running. If you go, I don't have the info here, but you'll see we're basically arcing out towards Duna or Mars. Hey. Why won't you change for me? There we go. So if we start looking, let's see here. It should be behind us. It's actually right. There. You'll see Duna is actually catching up to us. The reason being, if you think about it this way, the energy that's in the orbit, you're going to have a certain amount of energy here. You need to increase your energy if you want to orbit out here. So Duna is actually orbiting with more energy, even though it's further out. So because of that, obviously our orbit does not have as much energy in it. So Duna is catching up to us because we are traveling slower. You see here, Duna's velocity is 7,400, or 7 kilometers per second, 7.4. We right now are traveling at 6.5 kilometers per second. So we are definitely traveling slower than Duna. Why? I don't want you. Go away. So you'll see it coming in here. We're actually traveling underneath it. And if we go back to our map view, I guess we didn't transfer into the orbit yet. So at this point, right here, so we just changed. We basically have gotten close enough that we are now in Mars's gravity well, which is right up there. So we're now streaking through, which is, I don't think Falcon Heavy is going to get quite as close as this. Probably won't be able to see it, nor will we anyways be able to see it because the batteries are going to be running out here pretty quick after they made the burn. Basically, we're doing a flyby. I would have slowed down, but I killed my crew because I forgot about life support. And just like that now, we've crossed through, and we are now back into this orbit. And this is what the Tesla's going to do now. You can see right here's Earth, so it has gotten around faster than us. But basically, it's going to do this. It's going to constantly go in this circle, scooting around the sun's gravity well like so. It may make an appearance into another planet. You never know what might happen many orbits down the road, but regardless, this is what it's going to do pretty well permanently. So hopefully that answers some of the questions about orbital mechanics and about getting to other planets. The idea of how gravity wells work, that gravity is basically the law of nature when it comes to space flight, and you have to be able to know the numbers and the math and when to make burns and when to accelerate and what direction to accelerate. And you just got to remember that it always is going to take a burn on one side of your orbit to affect your other side of the orbit. Now, of course, like I said, if I wanted to match Mars, what you would do is, because remember I said we were slowing down as we reach the top of this orbit, when you get to that point, basically you want to speed up, and so that you're at the same potential energy, the same momentum, if you want to call it that, as the planet. When you do that, you're basically captured into that planet's orbit, that planet's gravity well, and then you're going to orbit just that planet. That's exactly how things would do in real life. You accelerate out to it, then accelerate to match. You just have to do it when the planet's there. If you do it now, well, you're going to stay this far away from the planet. Probably not ideal. Obviously, though, if you wanted to go the other way into the solar system, so if you wanted to go inside to Venus or Mercury or even to the Sun, you can't just burn straight to it. When we accelerated out to increase our orbit, then you would actually accelerate backwards. So you're actually accelerating to slow down because you're losing your potential energy in your orbit, and when you do that, you're going to start falling towards the gravity well of the Sun. And when you get closer and closer, you're obviously going to accelerate more and more because you're moving closer and closer to the gravity well. So that's the funny thing about orbital mechanics. You need to speed up to go out and slow down. And you need to, or I'm sorry, you need to accelerate to slow down and get into the inner part of it, and you need to almost kind of like slow down to accelerate out. It's kind of backwards. No matter what, you're always accelerating because you can't physically slow down in space. But it's not like a lot of the space movies do it. You don't just point and shoot. You don't have to thrust continually to get somewhere. All I did was that one burn to accelerate my orbit out there, and I had enough potential energy in it that I just traveled that far, and we flew right past it. So there's a lot of misconceptions, obviously, with science fiction. But I hope that helps. If you have any questions, throw them down in the comments. I'll be glad to answer them. And well, if there's enough questions, maybe I'll make a follow-up video with some more answers, and maybe next time I should do a stock Kerbal Space Program version that doesn't have the mods, so then I don't have to worry about the life support. Or maybe I should have just done unmanned version like I was originally going to do. But regardless, thank you all for watching, guys, and as always, take it easy.